Today we're going to look at inverse trig functions, and before I start I want to go, because I'm going to start off with the inverse of sine. And if you look on the graph, the sine graph, remember sine follows a curve, something similar to that. And what happens is when you use the horizontal line test, you're going to notice that the sine function is not a function because it doesn't pass the horizontal line test. So what we have to do is restrict the domain so it will have an inverse. But the only places where this works is between negative pi over 2 and pi over 2. So when you are finding the inverse of sine, you can only find exact values between negative pi over 2 and pi over 2. So on your unit circle, that will be quadrants 1 and 4. And remember, the exact values are the coordinates. I'm going to attempt to draw this unit circle. So this is 1, 0. Because this was 0. This is pi over 6. Pi over 4. Pi over 3. And then pi over 2. So the exact values are your coordinates. And remember, sine is the y coordinate. So for pi over 6, it was 1/2. Pi over 4 is the square root of 2 over 2. And for pi over 3, it's the square root of 3 over 2. And then if you go to negative pi over 6, and negative pi over 4, and negative pi over 3, then of course this is negative 1/2, negative square root of 2 over 2, negative square root of 3 over 2. Oh, I forgot about this one. This is negative 1, and this is positive 1. So those are the only sine values we could use when we're finding the values of sine inverse. In sine inverse, this is the symbol. Okay? So in the problem, they're going to give you one of these coordinates, and you have to give the angle that gave you the coordinate. Okay? So then now, and I'll do the examples at the end. Well, actually, I'll do one now. So it'll say something like, find the exact value of sine inverse of square root of 2 over 2. So if you notice, square root of 2 over 2 is right here at pi over 4. So your answer would be pi over 4. So the value that they give you has to be one of these 1, 2, 3, 4, 5, 6, 7, 8, 9. If it doesn't fall within those, then it's undefined. Okay, cosine. You know, cosine graph starts here, back here, and it looks something like this. Well, if we did the horizontal line test, again, the cosine graph would not be a function. Oh, this is 0, pi over 2, pi, 3 pi over 2, and then 2 pi. So that means that the only place where cosine is restricted is between 0 and pi. So this would represent, on our unit circle, this top half. Which is quadrants 1 and 2. And remember, if they ask you, so this is cosine inverse. So they ask you to find the exact value. I'm going to erase these off so I'll have room. Remember, it's referring to the coordinates around the circle. So, and remember, cosine is the x, so that's 0. This would be square root of 3 over 2. This will be square root of 2 over 2. And this would be 1/2. And let me fill in the radians. Pi over 6, pi over 4, pi over 3. And then this would be, excuse me, I did that one. It should be a 1. I'm sorry. And this is 0. And then over here, after pi over 2, you know this is 2 pi over 3, 3 pi over 4, 5 pi over 6. And then on this side, it'll be negative 1/2, negative square root of 2 over 2, and negative square root of 3 over 2, and then here it'll be negative 1. So those are the possible choices that they can give you. They ask you for cosine inverse of x. So the problem will be something like this. Find, or actually I'll type it so it'll look neater. Okay, so this is how it'll look. Find the exact value of cosine inverse of negative square root of 3 over 2. So you look around your circle, see which radian, which angle gave you that. And that would be this one, which is 5 pi over 6. And that's the answer. So now let's look at tangent. Okay, this is a tangent graph, and we did our horizontal line test. You see, tangent wouldn't have an inverse either unless we restrict it. And so tangent inverse is restricted between negative pi over 2 and positive pi over 2. but not including. So it's similar to sine, but you know it's undefined at those two asymptotes. Okay, so that would also be quadrant 1 and 4. But we can't include pi over 2 and negative pi over 2. So I won't put those values. So that's pi over 6, pi over 4, pi over 3, negative pi over 6, negative pi over 4, and negative pi over 3. So these are tangent. Remember, tangent is found by doing y over x. So at 0, we know it's 0. Pi over 6 is the square root of 3 over 3. Let's do these in a different color so they stand out. This is 1, and this is just the square root of 3. And then down here, these are the negatives. Because in this quadrant, tangent is negative. Okay? So the problem may look something like this. So it'll look something like this. Find the exact value of tangent inverse of square root of 3. So that would be right here. Sorry about the bell. Which is equal to pi over 3. So that would be your answer. Okay, these are a few examples of finding exact value, and if you want, you can use your unit circle to get the answer, or you can look back at the previous notes since I already labeled them. So the first one, you find where or what angle gave us a tangent of negative square root of 3 over 3, and that would be negative pi over 6. And then cosine, the inverse of 1, would be 0. And then sine, the inverse of negative square root of 3 over 2 would be negative pi over 3. And then that's how you do them. That's it for this section.